Hi, welcome to our first lesson. I'm going to jump right into what is chemistry and talk a little bit about how these lessons are going to work in general, but there isn't a do now today, sometimes we'll have that. So first thing I want to mention is how this component of class is going to work. Obviously, the responsibilities on your end is that you're going to interact with the materials that I upload, usually some sort of a video or an interactive simulation or something similar. You're going to need a notebook, something to write down your observations. I have this in future bullet points, so I don't know I need to write this, but you need a notebook. I'm going to suggest that you get some sort of actual like paper notebook to write stuff down in. I like the tactile sensation of writing, but I also, it's been shown, numerous studies have shown, I can find links if you really want me to, that having the act of writing actually helps with learning. It helps retention, it helps thought. So listening, seeing, and writing, it's almost like you're doing it 3 times. Obviously, with that, you need something to write with. Pen, pencil, I don't care. I can't see your notebook from here. I don't really feel the need to check notebooks, but if it seems like people are not engaging with the content, that's something, of course, we can revisit as time goes on. But obviously, the things that you're going to write down are any information or definitions that come in the video. If there's any sort of practice problems you get here or you get in actual in-person class, you're going to want some place to write down your thoughts or write down your work so that you can go back to it later. And then as you're watching these videos, if anything pops into your head, a question about this or even a question about something else, you should write it down so that when we come to class, you don't forget it. So the way I usually start these classes is I'm going to play some sort of video. And like I said in the previous slide, I want you to write stuff down. If you observe anything, have any questions that pop up, I want you to write them down. I need to try something really quick. I made 2 different videos from 2 different angles, and I'm going to try and get them to play together. There's a sync in the middle of it, or the beginning, so we're just going to watch. Let's see, walk over there, and I think I turn it on. Let's see how it works. Okay, I think that's actually pretty well synced up. I decided to do the demonstration once more because, as you can see in one of the videos, the $50 bill wasn't quite low enough in frame, so we get to see it one more time. So again, anything you observe, anything that's worth writing down, anything that's worth mentioning, this is the time. If you have any questions, it's especially good. And then I just walk around and turn off the other one. So if you have any questions, obviously we're going to get to them in the next few slides, but just as a bit of a ground rule to make sure everyone's on the same page, chemistry is, of course, the study of matter, energy, and how they interact with each other. Now this can be things like we're going to talk about atoms and elements, but this also includes things like how they bond with each other, physical interactions, and then I'm sure, as many of you are hoping, explosions, reactions, energy, all sorts of those kinds of fun things. Chemistry is broken down into several subgroups of chemistry. They're listed here. Each of them is their own like complete world that you can go off and get into. We're going to spend most of this year worrying about inorganic chemistry and maybe a little bit of physical chemistry, depending on how you want to define it. The other ones are kind of saved for future courses like AP or things you take in college. Oh, that wasn't supposed to be there, but it's okay. The way I like to look at chemistry is you can divide up our interaction with chemicals into like three main categories. And I used to show a big triangle uh, on the board, but that didn't really work because I was like breaking up the triangle into three parts, and then it dawned on me that already, in popular culture there exists, well, some popular cultures, there exists a three triangle component object. So like we're going to call this the Triforce of chemistry, and there's three main parts. There's the macroscopic, the atomic, and the symbolic. And I don't know if we want to call them, three different things. I don't know how we want to organize them. I like organizing them like that. Actually, that's not even how I'm going to do it. I'm going to clear those. I don't like that. I think the way I organize them on the coming slides is that we went with the macroscopic, and then I think there and there. I just like these three letters because they're my initials, so that kind of works nicely. But it doesn't really matter which one we call which. The idea is that you keep those three things in your mind: macroscopic, atomic, and symbolic. So going back to our video, the macroscopic observations are probably a lot of what you wrote down. You have clear liquid, we've got a $50 bill, there's some fire, but the bill doesn't burn. So you may have had some questions of like, why not? What is the liquid made of? I'm sure you have a couple others. If there's any I didn't get to, put a comment or let me know, when we get to class. But those are the big things that I would be looking for. What do the substances look like? What are their properties that you can actually see in the information there? How do they interact with each other? In terms of the atomic representation, we were a little bit less versed in this. This is where we get into the stuff that you probably haven't had a ton of experience with, but right now we're just going to kind of call it, drawing particles and drawing images. And so like we're going to represent, our liquid here. I'm going to spoil the ending slightly. If you do know what's going on, then, not going to be a great surprise, but really that liquid, you may have thought the liquid was something special. Maybe it looked like water, maybe it wasn't water. Oh, I cannot use yellow. That is not going to work at all. Orange. I hope that's orange, because I could actually see it. But we're just going to say that the liquid contains two components, and I'm going to show two different colors here. And the best way I can do that, or the best reason I'm doing that, is to say one of them reacts with flame and the other does not. So the idea here in kind of explaining what's going on in this demonstration is that when you have your dollar bill and it's wet with both of these liquids and then you set it on fire, the idea is that the one that reacts with the flame does react, and that's why you see the flame. The dollar bill itself isn't burning, it's the liquid that's burning. And then at some later date, one of those two components is gone, and the dollar bill is still wet with the other liquid that didn't react with the fire. So a lot of times in this atomic representation, we get a lot of these models where we represent like elements and compounds with like spheres, or we're writing a couple like English words there anyway, but this is our bit of a connective tissue between us in this world and these little atoms in their tiny world, and we're trying to represent on paper how these atoms interact with each other. Oh no, I'll be right back. The lights went out. The final branch of how we're going to break down our experimentation or demonstrations is the symbolic representation, and this involves element symbols and chemical reactions and phases, and probably more things that I'm not going to get to today that we're going to add to over time. But the idea is drawing a bunch of spheres and how they bounce into each other or leave a solution or burn. Those are all great, but that doesn't really tell me what chemistry is happening. And the best way we can talk about what chemistry is happening is to start naming these elements and compounds. But instead of using big long words, a lot of times we're going to abbreviate things, and as long as all of us are on the same page with what abbreviations we're using, these symbols can actually convey a large amount of information. So the main component of the flammable part of the liquid is it's rubbing alcohol, isopropyl alcohol, C3H8O, and it was a liquid, and it reacted actually with oxygen in the air. If you know this, there are two things that are needed for fire: oxygen and fuel, something to burn. So in this case, this is our fuel, the rubbing alcohol, and they will chemically combine. So this plus means they're not together yet. They're two separate particles, but when we draw this arrow, this means chemistry happens. And I'm going to draw a little triangle there to say happens in the presence of flame. That's what it means. And we're going to make carbon dioxide gas, and we're going to make a little bit of water vapor. Now, this is different than the water that was present in the mixture. So we're making a little bit more water that wasn't there before. I mean, the hydrogen and oxygen were there, but the water, the H2O, wasn't. I mean, yeah, there was some there, but this is some that's actually made in the fire. We do show these phases with these letters, so we're saying liquids and gases. And then the last thing I probably should do to make this all make sense is try and balance it. So I need 3 of these and 4 of these, but that's not going to work with this. So I'm going to double this, and I'll get 6, and then that's 8, so 4, 10, 9, I think. Did I do that right? 6, 16, 4, 9, 10, yep, okay. And so there's a lot of numbers here, there's big numbers and small numbers, and we're not going to get a ton into that today. Really the goal is to just make sure you have an idea of what these 3 components of chemistry are, and as we get into the year, we're going to use all 3 of them. Hopefully we start to get through some fluency and get to use them interchangeably. Thanks for watching.